In this video, we're going to look at double triangle problems that involve the use of a system in order to solve them. So this will be very similar to the previous lesson. If you haven't watched that, my advice would be to go back and watch that lesson first, but we're going to kind of kick it up a notch or take it to the next level. So I'm in the packet now with this question dealing with Jack and Jill, and it says they're 20 meters apart. Jack sees the top of the building at 30 degrees, whereas Jill sees the top of the building at 40 degrees. What is the height of the building? What's really nice about this question is whoever wrote it set it up really nicely for us, and that when they drew the picture, they labeled everything that we needed or wanted to know. So I'm going to go ahead by looking at the two right triangles, because just a brief reminder that the right triangles are the ones that we can use SOHCAHTOA with. So there's a third triangle in that picture. It's not a right triangle, and therefore I'm not going to use it to solve this problem. Just like we did in the previous lesson, I'm going to go ahead and I'm going to separate these two triangles. So for the purple triangle, it has a height of h. It has that 30-degree angle, and its horizontal piece is going to be the 20 in addition to the x. So x plus 20 or 20 plus x. And for the green triangle, again, that same height. This time the horizontal piece measures x units long, and the angle of elevation is 40 degrees. So again, very similar to what we did in the previous video, I'm going to go ahead and decide which trig ratio I use. Once I've decided which one to use, I'm going to write it right on my paper so the whole world knows that I'm using the tangent ratio. And I'm going to go through and do these one triangle at a time in no particular order. So I guess I'll start with the purple triangle. Tangent of the 30-degree angle is equal to the leg opposite, h, over the leg adjacent, x plus 20. And I'm going to go ahead and put that over 1 and cross multiply. So x is equal to the tangent of 30 times the entire quantity x plus 20. I'm going to make sure I wrap that x plus 20 in parentheses to remind myself that that's one factor. It all goes together. Because at this point I cannot substitute this into my calculator, I'm kind of at a standstill with respect to the purple triangle. There's not any more I can do. So at this point, I'm going to put that on the back burner and move on to the green triangle. Like I did for the purple triangle, I'm going to go ahead and start by writing down the ratio. Tangent of 40 degrees is equal to the leg opposite, h, over the leg adjacent, x. And again, I'm going to go ahead and cross multiply. So h is equal to tangent of 40 degrees times x. And like the purple triangle, I'm kind of at a standstill now. There's not a whole lot I can do with this because I cannot substitute it into the calculator. But what I notice at this point is I have these two equations, both of which are equal to h. And if they're both equal to h, it must mean that they're also equal to each other. So that'll be my next step here in my problem, is to go ahead and set these two equal to each other. So on one side of the equation, I've got tangent of 30 degrees times the quantity in parentheses, x plus 20, equals tangent of 40 degrees times x. On the left side, I see the use of the distributive property, so I'm going to go ahead and I'm going to distribute that tangent of 30 degrees to both terms inside the parentheses. So this becomes tangent of 30 degrees times x plus tangent of 30 degrees times 20 equals tangent of 40 degrees times x. And at this point, I'm going to take a step back and I'm going to take a look at these terms. And when I take a closer look at these terms, I can't help but notice that two of these terms have a factor of x in them. One of the terms does not. So I'm going to go ahead and I'm going to group together on one side or the other. It doesn't make a difference which side you pick, but I'm going to group all those terms that have an x in it. And I'm going to do this by adding or subtracting those terms away from one side of the equation or the other. So I'm going to go ahead and I'm going to subtract tangent of 30 degrees times x from both sides. And when I do that, I'm left with tangent of 30 degrees times 20, or 20 times the tangent of 30 degrees on the left side. And on the right side, I've got this either tangent of 40 times x minus tangent of 30 times x, or I could say x times the tangent of 40. Doesn't matter. Multiplication is a commutative operation. So tangent of 40 degrees times x, subtract tangent of 30 degrees times x. The important thing is that I have all my terms with an x grouped together. This is important because in the next step now, I'm going to go ahead and I'm going to factor. In particular, I'm going to go ahead and factor out that x. So I bring down on the left side my 20 times the tangent of 30 degrees. And on the right side, I've got x times in parentheses the tangent of 40 degrees, subtract tangent of 30 degrees. And if my goal or my mission is to solve for x, then to undo multiplying by that difference, I'm simply going to divide by that difference. And if I divide by that difference on the right side of my equation, then I also need to divide by that difference on the left side of my equation. So on the right side of my equation now I have x all by itself, which is exactly what I wanted to have. And on the right side of my equation, I have 20 times the tangent of 30 degrees in the numerator of my fraction. And in the denominator of my fraction, I have tangent of 40 degrees, subtract tangent of 30 degrees. And it's very important as you move through the steps with this algebra, which is pretty complex, you want to make sure that you're being a good math student and showing every step along the way and writing your work in a way so that whoever is reading it can follow it. So that's going to be very important, your communication of your knowledge of the material. You want your work to scream out at whomever is reading it and say, yep, this student really truly understands what he or she is supposed to do. So at this point, I'm thinking like, okay, I want to drag the calculator out and I want to plug that into the calculator. But I also want to make sure before I put that into the calculator that this is the last step in my problem. So if I go back and look at the question, it actually says not to solve for x, but it says to find the height of that tower. Because it asks me to find that height, I really do have one more thing that's necessary before I can substitute this in or plug this into my calculator. The height is either equal to this whole expression tangent of 30 times x plus 20 or tangent of 40 times x. I can use or substitute x into either one of those in order to find the height. I'm going to pick the green one just because it's less complicated and not as difficult to work with. So my h then, we said was equal to the tangent of 40 degrees times x. And x is this whole complicated fraction, 20 times the tangent of 30 degrees for the numerator, and tangent of 40 degrees, subtract tangent of 30 degrees for the denominator. One thing you may also be noticing about this question is they didn't tell us what to round to. I'm going to say, just to keep things simple, that we're going to round this to the nearest meter. And now, and only now that we're in the final stage of this question, am I going to go and I'm going to plug that into my calculator. I have to be very careful to plug it in exactly how I see it on my paper. So I'm going to start by typing in here the tangent of 40 degrees. You should be typing this in on your calculator at home too, so that you can make sure you understand how to put this into the calculator. And then I want the fraction, so times the fraction. And upstairs in the numerator of that fraction, I want 20 times the tangent of 40 degrees. And in the denominator of that fraction, I want the difference of tangent 40 degrees, subtract tangent of 30 degrees. And then just like we did yesterday, I would pause for just a minute and make sure that you indeed entered that into the calculator exactly how you wanted it to. So I'm going to pause and make sure that looks exactly how I want it to before I put the equals or hit the equals button. And I'm kind of glad I paused here because I wanted this to be a tangent of 30 degrees in the numerator. And at this point, everything looks good. I'm going to go ahead and hit equals, and I'm going to round to the nearest meter. So to the nearest meter, the height of that building is about 37 meters. So these problems can be rigorous, they can be challenging. It's going to be very important for you to use good algebra skills and show good algebra work on your paper.